Welcome, geometry students, to another Regents Review video. These are the solutions to the June 2016 Geometry Common Core Regents exam. These are the solutions to parts 2 through 4. These are the open-ended short response questions. Just a quick warning before we begin here. If you've seen my other videos in Algebra 1 and Algebra 2, just understand that geometry, the part 2s, 3s, and 4s are really in-depth and they take a long time. So this video might be a little long, but stay with us. We'll get through all the questions as quick and efficiently as I possibly can, and let's just get started very soon. Before we begin here, if you are here to copy my answers and hand them in for homework or whatever other reason you're here to copy my answers and you have a blank page in front of you, please refrain from doing so and get out of here. Please, if you're here to understand the material and to check your answers, or you need some sort of guidance, you've come to the right place. I am here to help you. But if you're here to cheat, you're not going to get much out of it, because I mean, if you're just here to cheat, then you're just taking my answers without understanding the material. The only way to get better at math is to actually do the math. All right, so just want to put that out there. All right, without further ado, let's go on to the part 2s, 3s, and 4s of the June 2016 Regents exam. Here we go. Number 25 says, describe a sequence of transformations that would map triangle ABC onto triangle DEF as shown below. The key word here is describe. Describe. Describe means be specific as you possibly can. So, to map triangle ABC onto triangle DEF, it looks like first it's translating by, let's see, 1, 2, 3, 4, 5, 6 units, because A has to map onto D. So it looks like it's being translated 6 units, and then it looks like it's being reflected over the x-axis. So if it says describe, you actually need to write a sentence. So I'm going to say a translation to the right by 6 units, followed by a reflection over the x-axis, would map triangle ABC onto triangle DEF. And it's a pretty fairly simple question. All right, that's number 25. Number 26. Okay, this is the question that I usually tell you in my geometry videos, that I do teach this differently, and teachers in many other schools and school districts, they teach this differently than I do. But it says here, point P is on segment AB such that AP to PB is 4 to 5. If A has the coordinates 4, 2, and B has the coordinates 22, 2, determine and state the coordinates of P. I'm going to show you 2 ways to do this, and the other way is not graphing. We're not graphing this at all. I'm going to show you my way, and then I'm going to show you one more way. So, this is the partitioning of a line segment problem, and it's on every single region, so you have to make sure that you know how to do this. I set up 2 ratios. I set up a ratio for the x values, and I set up a ratio for the y values. So the formula that you need to devote to memory is x minus x1 over x2 minus x is equal to the given ratio, and the other one is y minus y1 over y2 minus y is equal to the given ratio. Okay, so what's going to happen here is I'm going to say, all right, my 4 value is my x1, my 2 value is my y1, my 22 value is my x2, and my 2 value is my y2. So here we go. I'm going to plug in my values. We have x minus 4 over 22 minus x is equal to the given ratio of 4/5. So now we cross multiply. So we get 5 times x minus 4 is equal to 4 times 22 minus x. We distribute the 5 and the 4. We then get 5x minus 20 is equal to 88 minus 4x. And now we're going to add the 4x on both sides. And I'm going to add the 20 while I'm at it. So we get 9x is equal to 108, And now we're going to divide by 9 on both sides, and we get x is equal to the number 12. Okay? Now, for the y value, I'm going to plug in my value. So we get y minus 2 over 2 minus y is equal to the ratio of 4 over 5. So now we cross multiply. So we get 5 times y minus 2 is equal to 4 times 2 minus y. Distribute the 5 and the 4. We get 5y minus 10 is equal to 8 minus 4y. We're going to add that 4y on both sides, and we're going to add that 10 on both sides. So we get 9y is equal to 18, divide by 9 on both sides, and we get y is equal to the value of 2. Now, it says here to state the coordinates of P. So in order to state the coordinates of P, we actually need to say that P is the coordinate 12, 2. And that would give you full credit. That's how I do it. There's one more way that I want to show you that I think is perfect to get this question right. And it all goes back to the instructions. Look at this. If you look at your coordinates, there's something really special about the y values. The y values do not change. It's 2 and 2. That means that this line, line AB, is a horizontal line. Perfect. If it's a horizontal line, we could easily determine the partitioning of a line segment very, very quickly. And this is how it goes. If I have line AB, okay, and this is the coordinate 4, 2 and 22, 2, it says that it breaks this into a 4 to 5 ratio. That means that this has to be a 4 ratio and this has to be a 5 ratio. This is what I'm going to do. I'm going to count 4 spaces to the right in this case. So I start at 4 and I count 4 to the right. 1, 2, 3, 4, and I stop there. Then I count from here, I count 5 to the left. 1, 2, 3, 4, 5. We're not even close to meeting each other yet. Let's go 4 more. 1, 2, 3, 4. And then do 5 again. 1, 2, 3, 4, 5. Look at that, they touch. Now, I failed to mention to you that this is done on graph paper. Okay, this is done on graph paper. But you don't have to do it on graph paper because this is now 8 spaces. This is 8 spaces to the right. Well, 4 plus 8 is the number 12. So this coordinate over here, the x value is 12. 8 plus 4 is 12. And the 2's never changed. So this has to be 12, 2. So that's another way to do this question as well. But whatever floats your boat. All right, that is how you do that question. 27 is a very in-depth question for a part 2. And I'm surprised that they put this as a part 2. In my opinion, it should have been a part 3. But it says here, in triangle CED, as shown in the diagram below, points A and B are located on sides CE and ED respectively. Line segment AB is drawn such that AE is 3.75, AC is 5, EB is 4.5, and BD is 6. Explain why AB is parallel to CD. So the first thing that you want to discover is the little triangle that you see here, is triangle EAB similar to triangle ECD? And the answer is yes, they are. Because if you take the sides and you set them in proportion, first of all, I'm going to add this, and I get 8.75. And over here, I get 10.5. If I set these sides in proportion, they equal the exact same ratio. And you could verify that in your calculator. And again, if you have this TI Inspire, it's one great calculator to use. If you go to your calculator and you type in control division, 3.75 over 8.75, and you press the little equal sign, and you click on 4.5 over 10.5, it will tell you if it's true or false. And it is true. So therefore, these two fractions are the same ratio. So therefore, these two triangles are similar by side angle side. But where's that angle coming from? Angle E is reflexive. So these two triangles are similar. Therefore, the angles are also congruent. So it says explain why AB is parallel to CD. Your goal is to say that angle EAB right over here is congruent to angle ECD. Now, those two angles are corresponding because it creates that F shape. And these two angles are now if two angles are corresponding, they prove the lines parallel to each other. So this is a very long answer explanation. Be prepared to type out this to write out this explanation. So, as shown above, triangle AEB is similar to triangle CED by side angle side because the corresponding sides are in proportion. And angle E is reflexive. If you didn't state that, how could you prove the lines parallel by those angles being congruent? You had to state that they were similar first, okay? So then we say that since these two triangles are similar, it can be proven that angle EAB is congruent to angle ECD because they are corresponding to each other. Now, angle EAB and ECD, these are the angles that I was talking about to prove the lines parallel, okay? So now we keep going. Then we say it can then be proven that line AB is parallel to line CD because if two lines are cut by a transversal and form two congruent corresponding angles, then the lines are parallel. And that is how you prove those two lines to be parallel to each other. All right, there's your answer explanation, and that is how you do question number 27. Okay, moving on to 28. Find the value of, find the value of R that would make the equation sine of 73 degrees is equal to the cosine of R true when 0 degrees is less than R, which is less than 90 degrees. Explain your answer. The one thing that you have to remember is that angle R has to be 90 degrees minus whatever the angle is for sine. Because, and we're going to explain this in our answer, sine and cosine are cofunctions which are complementary. So R must equal 90 degrees minus 73 degrees. So R is equal to 17 degrees. That is your answer, and your explanation is because sine and cosine are cofunctions which are complementary. Now, if you do not believe me that the sine of 73 is equal to the cosine of 17, let me prove you wrong. If you go to your calculator and you type in sine of 73 and you click on the little equal sign and you click on cosine of 17 degrees, look at what it says. It says it's true, so therefore we know that we got the right answer of 17 degrees. And that is how you do question number 28. All right, moving on to question number 29. It says here in the diagram below, circle 1 has radius 4, while circle 2 has radius 6.5. Angle A intercepts an arc of length pi, and angle B intercepts an arc length of 13 pi over 8. Dominic thinks that angles A and B have the same radian measure. State whether Dominic is correct or not correct and explain why. Okay, there are two ways to answer this question. either one, you could use the trigonometric formula, sector length is equal to the radius times theta, which I'm going to show you in just a moment, or you could prove that these are the same ratio and that they are in proportion, okay? Because all circles are similar, so therefore its radii and its arc lengths are in proportion as well. I'm going to show you both of them in just a moment. But the first way that I want to show you is the formula S equals R theta. This might be a new formula to some of you. S equals R theta. This stands for the sector length, okay? R stands for your radius, and that little symbol that you see there, that is theta, T-H-E-T-A, theta. It's a Greek letter, and that means radian measure. So what is sector length? I always tell my students sector length is the length of the crust of a slice of pizza. That's what sector length is. So these here are sectors, okay? So Dominic thinks that angles A and B have the same radian measure. Explain if he's correct or not correct. So what we're going to do is we're going to apply S equals R theta to both of these circles. So for circle 1, your sector length is equal to the radius, which is 4. Oh, I'm sorry. My apologies. The sector length is pi. Pi is equal to the radius, which is 4 times theta. We need to solve for theta. So divide by 4 on both sides. Theta is equal to pi over 4. That is the angle measure of theta. Now, for circle 2, we're going to do the same thing. So we have the sector length of 13 pi over 8. Is that equal to 6.5 theta? Well, if we divide by 6.5 on both sides, do we get 13 pi over 8 divided by 6.5? Is that equal to pi over 4? Well, if I do control division, 13 over 8 over 6.5, we get 0.25. 0.25 is the same thing as 1/4. Notice how I didn't put the pi in, by the way, because pi puts a whole bunch of decimals after it, and I don't want that. 0.25 is the same thing as 1/4. So 1/4 is the same thing as, well, it's just 1/4 times pi. 1/4 pi is the same thing as pi over 4, which is equal to theta. So Dominic said that they have the same radian measure. Is he correct? You say yes. Yes. Oops. Why is it? Okay, there we go. Yes, Dominic is correct because both equations yielded the same result of theta equals pi over 4. And that's it. So that would give you full credit. That's one way to do this problem. The other way to prove this problem is say, hey, wait a minute. Circles are similar. So all circles are similar. So I could set the radius and the sector length in proportion to each other. So is 4 over pi equal to 6.5 over 13 pi over 8? I'm going to plug that into my calculator and verify it. So, control division, 4 over pi, is that equal to control division 6.5 over control division 13 pi over 8. And if it's true, then it's good. Hey, it's true. So therefore, the angle measures are congruent to each other, because if you have sector lengths that are in proportion to each other, the angles are congruent because circle 2 is just dilated. And remember, dilations preserve angle measure. So Dominic is correct by that as well. Either one of those would have been perfectly acceptable. Question number 30. A ladder leans against a building. The top of the ladder touches the building 10 feet above the ground. The foot of the ladder is 4 feet from the building. Find, to the nearest degree, the angle that the ladder makes with the level ground. Okay, draw yourself a diagram. So you need to draw a right triangle. All right. So here's my little stick figure, okay? And the ladder touches the building 10 feet above the ground. So this is 10 feet, okay? So, by the way, this is your right angle. So this is your hypotenuse. This is your opposite side. Then it says the foot of the ladder, so that's the foot, is 4 feet from the building. So this over here is 4 feet, and that is your adjacent side. So we are using SOHCAHTOA. So if we're given the opposite and the adjacent, we are using tangent. So find to the nearest degree the angle that the ladder makes with the level ground. So we have the tangent of theta is equal to the opposite over the adjacent. That's the standard form. So the tangent of some angle, I'm going to call this x. So the tangent of x, because we're trying to find this, is equal to the opposite side, which is 10 over the adjacent, which is 4. Now, to solve for an angle measure using trig, you need to use inverse tan, or tan negative 1, of 10 over 4, and we're going to plug that into our calculator. So the inverse tan of 10 over 4, that is approximately equal to 68 degrees to the nearest degree. So x is approximately equal to 68 degrees would be your correct answer. All right, moving on to question 31. This is a construction. Before I begin this construction, understand that I'm going to do the construction on the computer first, and then immediately following this construction, there's going to be the same construction, but in a more hands-on way. So if you want to skip to that right now, by all means go ahead, or if you want to watch both, you could do that as well. All right, question 31 says, in the diagram below, radius OA is drawn to circle O. Using a compass and straight edge, construct a line tangent to circle O at point A. Leave all construction marks. So what you have to do is you need, first of all, you need a compass and a straight edge. So you need to construct a line tangent. But wait a minute. You need to know this theorem before we begin. A tangent is perpendicular to a radius. Okay? So that means that we need to create the perpendicular line passing through point A. This is the example of drawing a line perpendicular through a point on the line. Okay? So, we're going to put this down here. What we're going to do is, step 1, we are going to extend this line outwards. We need it longer. All right, there's my longer line. Now what I'm going to do is I'm going to bold point A. I'm going to place my compass point on A, and I'm going to expand my compass arm a good distance away, so if I swing it, I touch my line at 2 different points. Okay? So these 2 points are my intersection points. Now, if you then place your compass point back on the intersection point and extend the length of the compass arm, and you swing below and above, you will create intersection points to draw your perpendicular line. Now, you could just draw the bottom one or the top one, that's fine. You do not have to draw both, but I like to be accurate, so I personally draw both. So now from here, you just take your straight edge and you connect this point here down to this point, and you draw your straight line. And that, ladies and gentlemen, is how you construct a tangent to circle O at point A. All right, so the next section of this video is I'm showing the construction in a more hands-on way. All right, so this is question number 31 from the June 2016 Regents exam, and this is the construction, and this is a hands-on approach if you do not like the computer software that I use. So the question says, in the diagram below, radius OA is drawn to circle O. Using a compass and straight edge, construct a line tangent to circle O at point A. Leave all construction marks. So our job is to construct a tangent through passing through point A. Now remember that a tangent is perpendicular to its radius. And that's really important to understand how to do this construction, because your job is to actually construct a perpendicular line passing through point A. This is your classic example of constructing a line perpendicular to a line with a point on the given line. So the first thing that we're going to do is we are going to actually extend our line outside of the circle. Now remember, your job is to pass through point A because that's where your tangent line has to be. So in order to complete this construction, I'm going to take my compass and I'm going to place my compass point directly on point A. I'm going to pick a reasonable size arc setting or compass setting, and I'm going to swing my compass, and it has to pass through this line 2 times. And as you can see, it does that here once and then twice. Now, using my compass, I'm going to expand the compass arm a little bit more. I am then going to go back to my intersection points, and I'm going to construct an arc above and below this arc. So I go once below, and I do that below again. Now, as you can see, these are not touching, so I need to go back and make this a little bit longer. And now they're touching, and now I just swing it above. Now, you do not have to go above. That's not required. You could just stop here, and that would be perfectly fine. But I like to go above and below just for more accuracy, just to be a little bit more accurate on this question. And those are your 2 intersection points. Now I just take my straight edge, and I connect these 2 intersection points, and at the same time passing through point A. So I'm just going to connect these 2 intersection points, passing through point A and intersecting at the other point. And that is how you construct a tangent to circle O passing through point A. And you could conclude, if you really wanted to, that a tangent is perpendicular to its radius, so you are actually creating right angles. All right, on to the part 3s. Here's question number 32. And it says, a barrel of fuel is a right circular cylinder where the inside measurements of the barrel are a diameter of 22.5 inches and a height of 33.5 inches. There are 231 cubic inches in a liquid gallon. Determine and state to the nearest tenth the gallons of fuel that are in a barrel of fuel oil. So, the first thing that we need to determine is the volume of the barrel. So, the barrel, they specifically said that it is a right circular cylinder. So what I'm going to do is I'm going to draw myself a right circular cylinder. Just like so. All right, so here is my cylinder. Okay? And it specifically says that it has an inside diameter of 22.5. So if your diameter is 22.5, your radius, which is 1/2 of the diameter, so the radius is going to be 11.25 because that's 1/2 of 22.5. And it says that the height is 33.5. So now, let's find the volume of the cylinder. So the volume is equal to pi r squared times the height. Volume is equal to pi times the radius, which is 11.25 squared times the height of 33.5. So therefore, your volume, well, let's just plug that into our calculator. So we get pi times 11.25 squared times the height of 33.5, and that gives us a volume of 13,319.862. Okay, so if I go back, 13,319.862. It's okay to round to about 3 decimal places. That's perfectly fine. All right, because you will still get the right answer. Now, it says there are 231 cubic inches in a liquid gallon. Determine, state to nearest tenth, the gallons of fuel. We don't want the volume. We want how many gallons are in this cylinder. So what I'm going to do is I'm going to take 13,319.862, and I'm going to divide 231, and that will give us approximately 57.7 gallons. And that is the approximate number of gallons that is in one right circular cylinder with these measurements. All right, that's how you do question number 32. Moving on to question 33. Given that parallelogram ABCD, line EFG, and diagonal DFB, prove that triangle DEF is similar to triangle BGF. So since we have no angle measurements, the only way to prove these two triangles similar is by angle. These angles over here are vertical. I'm going to call this angle 3 and angle 4. And these angles up here are angle 1 and angle 2. Those are congruent as well. And we are going to explain that in the proof. Pardon me, I'm just going to type up statements and reasons for a statement reason chart. Okay, so here I have my statements and my reasons. Let me change the font here for a second, make it bold, nice and bold. And change it to this. All right, so let me just draw a quick T-chart. And we are ready to roll. So we have our statements and our reasons. So the plan to prove triangle DEF is similar to triangle BGF is by angle-angle similarity. Now this is a parallelogram. So a parallelogram, just remember, has opposite sides that are parallel. That's going to come into play very shortly. So let's list our givens first. So number 1 is parallelogram ABCD, line EFG, and diagonal DFB. And your reason is given to you. Number 2, I'm going to say that AD is parallel to BC. And the reason why I'm saying this is your goal is to prove angle 1 is congruent to angle 2. So your reason is, in a parallelogram, opposite sides are parallel. Okay? Now on to number 3. Now I'm going to say that angle 1 is congruent to angle 2. And your reason is, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay? So angle 1 and angle 2 are in fact alternate interior angles because they create that Z formation. Now number 4, I'm going to say that angle 3 is congruent to angle 4. Your reason is vertical angles are congruent. And last but not least, number 5. We just proved two pairs of angles congruent to each other. So I'm going to say that triangle DEF is similar to triangle BGF, and your reason is angle is congruent to angle, and you are done with that proof. All right. And let's go ahead and move on to question number 34. Okay. 34 was definitely an interesting one. 34 says, in the diagram below, triangle A prime B prime C prime is the image of triangle ABC after a transformation. They're not being specific about it. But it says, describe the transformation that was performed. Now, you need to do a little bit of work to get this right. It says describe. You need to be specific. Okay. This looks like a dilation because the triangle is getting smaller. Actually, no, I'm sorry. The triangle is getting bigger. Triangle A prime B prime C prime is the image. So therefore, we are going from the little triangle ABC, to getting a bigger triangle, A prime B prime C prime. So your answer is going to be a dilation. But we can't stop there. It says describe. If you just wrote dilation, you got it wrong. They won't even give you credit for that. You need to state the scale factor. Well, we are going from BC to B prime C prime. What is the distance or the length of BC? Well, 1, 2, 3, 4, 5, 6 units. And B prime C prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is a dilation of 5 halves. Because 15 over 6 is the same thing as saying 5 halves. That's just a reduced fraction. So a dilation of 5 halves that is centered at the origin. Why is it centered at the origin? I'd be happy to show you why. If you take rays, now remember what a ray is. A ray is drawn from one point and extends in one direction. So this is the origin 0, 0. Watch what happens. If I draw a ray and pass through A and go all the way to A prime, it lines up perfectly. If I go from the center of dilation, which is the origin, go to B and B prime, they pass perfectly. And if I go from the origin to C, then to C prime, they pass perfectly. Sorry, I drew that a little bit off here. There we go. They pass perfectly. So clearly your center of dilation is in fact the origin. And that would give you credit. So a dilation of 5 halves centered at the origin. Then it says here, explain why triangle A prime, B prime, C prime is similar to triangle ABC. So you had to state that dilations preserve angle measure. So triangle A prime, B prime, C prime is similar to triangle ABC by angle-angle similarity. Similarity. Where angle A prime is congruent to angle A and angle B prime is congruent to angle B. Okay? Or you could say that dilations preserve scale factor, so you could say that the ratios of all of the sides are in the same ratio. That could be acceptable as well. All right. Ooh, now we're on to the part 4s. The part 4s on this particular exam, they were quite interesting questions. Okay. Let's take a look at question 35. Given quadrilateral ABCD with diagonals AC and BD that bisect each other. Okay, so AE is congruent to EC and BE is congruent to ED because they bisect each other. And angle 1 is congruent to angle 2. It says here, prove that triangle ACD is isosceles, and then prove that triangle AEB is a right triangle. Now, I just want to tell you this ahead of time. What's so interesting about this proof is that you do not prove a single triangle congruent to each other. This is not a congruency proof. Okay, so I'm going to go through this quite slowly. Let's take a look at number 1. We have to list all of our givens first. So I'm going to say all the information. Quadrilateral ABCD with diagonals AC and BD that bisect each other. And angle 1 is congruent to angle 2. Your reasons given. Now that I just listed all my givens, I want to explain what we are trying to do. We are trying to prove that AD is congruent to CD because it says isosceles triangle. So your goal is to prove that quadrilateral ABCD could possibly be a rhombus or a parallelogram. Either one of those to prove some sort of relationship. And then we can prove that AD is congruent to CD, or angle 2 is congruent to this angle up here, and that could be the isosceles triangle. Now, to prove that triangle AEB is a right triangle, we need to prove that the diagonals are perpendicular. In essence, that's the property of a rhombus, so we need to prove that this is a rhombus. So, the main idea, we're going to prove that this is a rhombus. Okay. Statement 2. I'm going to say that quadrilateral. Oops, sorry, I spelled that wrong. Quadrilateral. ABCD is a parallelogram. 2, for the reason is in a parallelogram, diagonals bisect each other. That's a C, by the way. Sorry about that. Each other. Okay. Now, number 3. I can now say that side AB is parallel to side CD. So AB is parallel to side CD because in a parallelogram, opposite sides are parallel. Now, what does this lead to? What conclusion does this lead to? Well, what I didn't put here is I'm going to call this angle up here 4, and I'm going to call this angle 3. Because angle 1 will be congruent to angle 3, and angle 2 will be congruent to angle 4 because the lines are parallel. So I'm going to say that angle 2 is congruent to angle 3, and that angle 1... No, I'm sorry, not angle 2 is congruent to angle 3. I'm going to say that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And that's clearly visible because 1 and 3, 2 and 4, those are the alternate interior angles. So number 4 is going to be the reason if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay? Moving on to number 5. Now I'm going to say that angle 2 is congruent to angle 3, and angle 3 is congruent to angle 4. Let's talk about why I'm doing that in the first place. So I just said angle 2 is congruent to angle 3, and angle 3 is congruent to angle 4. Why am I saying that? Well, angle 1 and angle 2 are congruent to each other because they tell us in the given. Angle 3 and angle 4 are also congruent to each other because AC is a bisector. And we could prove this by the substitution postulate. Because if 1 is congruent to 3 and 1 is congruent to 2, 2 therefore is congruent to 3 and 3 is therefore congruent to 4. I know it's a lot of letters and numbers and such, but just bear with me. 3 has to be congruent to 4 because 3 is congruent to 1 and 1 is congruent to 2. All of that stuff is proven by the substitution postulate. And if you don't know what the substitution postulate is, make sure that you review that because it does show up sometimes on the Regents. Okay? Let's keep on going. So, number 6. I'm now going to say that triangle ACD is isosceles. Your reason is the base angles of an isosceles triangle are congruent. Well, how do we know that? Well, I just said that angle 2 is congruent to angle 3. If you have two base angles that are congruent, the triangle is isosceles. Fantastic. So what I like to do personally is I like to draw a little squiggle just to tell myself, okay, you got the first part done. Let's keep going to prove that second part. And the second part, remember, is to prove that triangle AEB is a right triangle. So, number 7, I'm going to say that AD is congruent to DC. Your reason is the definition of the isosceles triangle. Definition of isosceles triangle. Now, ladies and gentlemen, if you have two sides, and I said AD and CD, these two sides are congruent. Notice how they're next to each other. Those are called consecutive sides. And if consecutive sides are congruent in a parallelogram, the parallelogram must be a rhombus. That's really important information for the future, and that's what we're going to prove right now. So we're going to say that since we just said it's a parallelogram, I'm going to say that, I'm going to say quadrilateral. So quadrilateral ABCD is a rhombus. And your reason is consecutive sides that are congruent proves a rhombus. Okay? Now let's go on to number 9. Number 9 then states that angle BEA is a right angle. And your reason is perpendicular lines form right angles. And last but not least, number 10, I'm going to say that triangle AEB is a right triangle. And number 10, because a right triangle has one right angle. Now, I want to make one thing clear. And I know I'm going to get maybe a comment or two. You see how I said number 9, it says angle BEA is a right angle because perpendicular lines form right angles? You do not have to state that AC is perpendicular to BD because it's a rhombus. So it is implied already that since it's a rhombus that AC is perpendicular to BD because that's a property of a rhombus. Now look, if you want to insert a step before that, you could call this 9B and you could insert 9A and say that AC is perpendicular to BD because the property of a rhombus. That's fine, but you don't have to do that. But just in case you're very either passionate about geometry like I am, or if you just want to make sure that you're 100% correct, you could put that as well, but you don't have to. All right, and that is the entire proof. You probably can't even see that on your screen, but that is, ladies and gentlemen, the entire proof. All right, and if you need to pause the video or go back and rewind, I highly suggest that you do that now, just in case you missed anything. The last question on the Regents. Here we go. It says here, a water glass can be modeled by a truncated right cone, which is a cone cut parallel to its base, as shown below. Cool. The diameter of the top of the glass is 3 inches. The diameter of the bottom of the glass is 2 inches, and the height of the glass is 5 inches. The base of the diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Explain why. First things first, I'm going to draw and label. They told me that the diameter is 3 of the glass, so therefore your radius is 1.5, and your height of the glass is 5, and your diameter is 2. So therefore your radius is 1. Okay? Now if we go over here, you see this little section right here? That's the glass. So it has all of the same measurements. So this has a measurement of 3. This is 1.5 for the radius. This is 5. And that's about it. So it says here, the base with a diameter of 2 inches. So the base with a diameter of 2 inches right here must be parallel to the base of 3 to find the height of the cone. Explain why. Well, we need to remember what we're doing. Look at this. We are my apologies. We are trying to find out. We're trying to find the height of the cone. This is the height of the cone. This height right here, this is the height of the cone. But we need to set up similar triangle proportions to solve it. Look, ladies and gents, we have, actually, I'm going to change the color for a second. We have the height of the cone, which is the big triangle, and I have a little triangle in here like that. These two triangles are similar by angle. Why are they similar by angle, you might ask? Well, because this angle down here, let me change that. This angle down here is reflexive, and the altitude of a cone is perpendicular. So therefore, these are right angles. So these two triangles are similar by angle. So we are going to say, as our answer, that similar triangles are required in order to set up and solve a proportion. And if you want to be very specific, you could say that parallel lines make congruent corresponding angles. And that's where we get these right angles from. And of course, these two angles are congruent as well. Okay, so that's how you do that part of the question. Now let's go on to this one. Determine and state in inches the height of the larger cone. All right, I'm going to take a quick picture of this figure. And I'm going to move it to the next page. So just bear with me as I take a picture real quick because it just makes my life so much easier. I don't know if my volume on the computer is on, so just if you're wearing headphones, cover your ears for a second. There you go. Sorry if that was loud. All right, and I'm going to paste it over here. All right, cool. So we have this. And it says here, determine and state in inches the height of the larger cone. When it says larger cone, it's talking about the whole thing. Okay, well, here's the problem. We know that this height is 5. I don't know what the height of the smaller cone is, so I'm going to call that x. And this whole piece, I'm going to call this x plus 5. Now, if the radius of, if the diameter of the top is 3, and the diameter of the bottom is 2, your radius over here is still 1, by the way. So we do need the radius in order to help us for both. So let's talk about the big one first, the big cone. The big cone is x plus 5 is in proportion to its radius of 1.5. And this is proportional to x over 1. Again, these are all similar triangles right here. Cross multiply, you get x plus 5 is equal to 1.5x. Subtract the x on both sides. You get 5 is equal to 0.5x. And then last but not least, I'm going to divide by 0.5 on both sides. And you get x is equal to 10. Now to find the height of the larger cone, you have to take your x value and plug it back in. So the height of the larger cone is x plus 5, so that's 10 plus 5, so the height of the larger cone is 15. All right, that's how you do that part of the question. And then last but not least, it says determine and state to the nearest tenth of a cubic inch the volume of the water glass. Well, there's no formula to just solve for the volume of this water glass. You need to take the volume of the big cone minus the volume of the little cone. But what's great is we just found the height of the larger cone. So let's first find the volume of the larger cone. And what's great is we just found the height. So that means we have 1/3 pi r squared times the height, right? We get 1/3 pi. The radius of the larger cone is 1.5 squared, and we just found the height to be 15. Plug this into your calculator. So we get 1/3 times pi times 1.5 squared times the height of 15, and we get 35.343. So we get 35.343, and let's find the volume of the small cone. That is going to be 1/3, again, 1/3 pi r squared times the height. That is 1/3 pi, and the radius is 1 squared, and the height is 10. So that is equal to, let's see what we get on our calculator. So 1/3 pi times 1 squared times the height of 10. And that is approximately 10.472. 10.472. To find the volume of the water glass, it's the volume of the large cone minus the volume of the small cone. Okay, so that is going to be 35.343 minus 10.472, and it says round to the nearest tenth of a cubic inch. The volume of the water glass is 24.9 when you plug that into your calculator, and that is how you do question number 36. All right, I hope this helped. Please hit that subscribe button, and please visit my website at www.nysmathreadersprep.com for more content in math and more math videos. And I hope to see you soon.